Hey pre-calc students, welcome to today's lesson on evaluating inverse trig functions using special triangles. So if you think back to a couple lessons ago, inverse trig functions help us find the angle measure. And in order to do that, you need to have the side lengths known. So it's super important for you guys to remember that inverse trig can only work if you know the ratio of the side lengths that correspond to that trig function. So if you don't, in the cases that we're going to be studying today, so if you're not given the side lengths, it's possible that the angle is a quadrantal angle. So remember, quadrantal angles are the ones that land exactly on the x or the y-axis. All right, so assume that everything in this lesson is no calculator, okay? Even if I may forget to say it at times. All right, so what do you need to know about inverse sine? And I just realized when I copied and pasted, I forgot to change these. So this is inverse cosine and inverse tangent. Oops. Okay, so inverse sine has a specific restriction in terms of what angles correspond to that inverse trig function, okay? And it's based on the graphs of these trig functions. It's something that you guys maybe graphed last year in advanced algebra, or we'll discuss in further detail in another class, okay? But these restrictions are based on the graphs of sine, cosine, and tangent of the original trig functions. So sine inverse is restricted when you're finding sine inverse. You have to give an angle that is between -90 and 90 degrees. Okay, it can be equal to 90. So just as a heads up, that means that you're restricted within this area here. Okay, so those quadrants. So that's Q1 and Q4. But again, you can't just pick any angle with a terminal side that lands in quadrant 1 or quadrant 4. It has to be an angle between -90 and 90. Like I said, it can equal 90. All right, for cosine, when you're asked to find the inverse cosine of a ratio or of a specific number, that one is restricted between 0 and 180. It can be equal to 0 or 180. So again, you can, when I was talking about sine inverse, you could have had an angle be 90 degrees, right? Or 0 or -90. As it could have landed on the x or y axis. It could be quadrantal. So here, same thing. It could be land exactly on 0 or 180 or anything in between. Okay, so this is cosine inverse. And that's probably what I should have done over here too. So that's where it's restricted. Okay. So cosine is over here. So that's quadrants 1 and 2. Okay, you will see some teachers write it as, let me think, it goes like this, cosine and sine. Those are for the inverses. Okay, so those are the quadrants that correspond to the restrictions. Okay. And then finally, tangent is like sine. You'll see some teachers talk about the restrictions like this, cotangent, inverse, tangent. So they'll write it like that. For the domain restrictions, or sorry, not domain restrictions, the angle restrictions. So again, like I said, this is like sine. It's restricted within these quadrants, Q1, Q4. And the angle head that you give needs to be between -90 and +90. It can equal exactly -90 or 90. So again, you can have quadrantal angles. Now, it is still important for you guys to know that there are the special triangle lengths, right? Are always 1, √3, and 2, but it's important for you to know where the √3 goes, where the 1 goes. So remember, 30 is across from the 1, 60 degrees is across from √3, and the hypotenuse is always 2. You also need to remember that the 45, 45, 90 triangles, right? You have to know their side lengths. So that's 1 root 2. You don't necessarily have to write this if you already kind of have it memorized. Sorry for how crazy this triangle looks. Super sad. Okay, and then also remember that for quadrantal angles, we use their ordered pairs, right? So a degree of 0 would be 1, 0. So it'd be 0, 1. This would be -1, 0. And this would be 0, -1. And of course, tangent is sine over cosine. So that's all stuff that this is all stuff that we've been talking about for the last couple lessons. The important thing, guys, is we're going to be asking you to go backwards, essentially. We're going to be giving you the side lengths, and you have to tell us what angle we're referring to. Just pay attention to the restrictions, okay? Okay. So first and foremost, when I look at these problems, I automatically think of the restrictions. So for sine inverse, right? For sine inverse, you are restricted to quadrants 1 and 2, right? Quadrants 1 and 2. Or sorry, repeat. Quadrants 1 and 4. Quadrants 1 and 4. Q1, Q4. Brain fart. Okay, so that means that my angle could be exactly from -90 or all the way to +90, anything in between, okay? So what you do is you got to ask yourself, okay, well, sine is normally opposite over hypotenuse, right? So which angle from my special triangles, when I find opposite over hypotenuse, would give me √3 over 2? So take a look at your triangles. Let's pay attention first to the triangle that has a √3 in it, right? The 30, 60, 90. So in a 30, 60, 90 triangle, let's say I focus on the 30 degrees. And if I use that as my reference angle, would opposite over hypotenuse give me √3 over 2? Opposite over hypotenuse, if I use the 30-degree angle, would not give me √3 over 2. That would give me 1/2. So then my 30 degrees is not my reference angle. That means it's got to be 60. So if I do opposite over hypotenuse from the 60 degrees, I get opposite is √3 and hypotenuse is 2. But notice, they want my sine to be negative. Okay, so what that means is, well, we know the reference angle is 60, right? And we know we're restricted to quadrants 1 and 4. So we're restricted to these two quadrants. Okay, sorry that I said 1 and 2 earlier. Okay, so we're going to use a reference angle of 60. So we have two possibilities here. We have that it could be positive 60 degrees or negative 60 degrees. Okay, so those are your two possible angles that we're working with. So think of a terminal side there and a terminal side here. Okay, so there's two possible triangles. I'll do them in different colors so you guys can see the difference. How do you know which one you want? Do you want 60 degrees in quadrant 1 or 60 degrees in quadrant 4? Well, label the side lengths of these triangles. So across from 60 is √3, right? Across from 60 is √3. In this case, it would be negative because you went under the x-axis, you went down. So that distance is negative. Hypotenuse is 2. And then this would be across from the 30, right? Across from 30 would be 1. Which of those triangles gives me, if I use 60 as a reference angle, negative √3 over 2? It's the one that's in red, which is below the x-axis. So the angle that I have to give them, remember, has to be between -90 and +90. So I need to use this guy right here. That angle measure is negative 60 degrees. Now, some of you might be thinking, well, how come we can't give the angle 300, right? Because 300 would go down and around and end in the same spot. Well, 300 is not within the restriction. 300 is too big to be in this interval, right? Between negative 90 and 90. So you can't give 300 as an answer. Your only possibilities are 60 or negative 60. All right, so the restrictions for cosine are different, right? The restrictions for cosine, if you look up here, are quadrants 1 and 2. So I am allowed to give them an angle between 0 and 180. Again, all of this stuff, all these restrictions come from the graph of the original sine function, cosine function, and tangent function. So feel free to Google it and figure out why they are restricted to these angles. All right, so they're asking the cosine of which angle, right? Cosine inverse of negative root 2 over 2 is asking you what angle has a cosine of negative root 2 over 2. Well, cosine is adjacent over hypotenuse. Now, root 2 appears in the 45, 45, 90 triangle. So I'm going to look at my 45, 45, 90 triangle and figure out which angle, technically, right, this is kind of an easier one because they're both the same angle, 45 and 45. I'm going to ask myself, if I use 45 and I take adjacent over hypotenuse, would it give me root 2 over 2? We'll worry about the negative in just a second, but let's see. Adjacent would be 1. Hypotenuse would be root 2, right? If you rationalize, you get root 2 over root 4, which is root 2 over 2. I know some of you guys skipped this step, but I'm going to show it anyway. So 45 degrees, either of the 45 degrees, adjacent over hypotenuse would be 1 over root 2, and if I rationalize, I get root 2 over 2. So we know that the reference angle is 45 degrees, okay? That's just the reference angle. Now let's worry about the negatives and all that stuff. So we know we're stuck between these two quadrants, right? Okay, so the reference angle is 45 degrees. So it could be terminal side here of 45 degrees or over here, reference angle of 45 degrees, okay? All right, so this could be a possibility or this could be a possibility. Now label the side lengths. So label the rest of the triangle. So this would be 45 degrees, 45 degrees. This is 1, 1, root 2. Everything in quadrant 1 is always positive. But as I go left, so take a look at the side lengths. This would be negative 1. This would be positive 1. So when you go left or down, remember in the previous problem, I went down root 3. So left is also negative. Now I'm going to ask myself which angle, right? Which triangle, sorry, the blue or the red would give me a negative root 2 over 2 if I do adjacent. So if I use 45, the positive 45, adjacent over hypotenuse would be 1 over root 2, and that would be positive. So I need this angle with a reference angle of 45. But here's where you have to be careful. That angle is not 45. That's the terminal side, right? So what angle has a reference angle of 45 and is in quadrant 2? Think about it. Right? What angle is in quadrant 2 and has a reference angle of 45 degrees? So remember, this would be the full 180 degrees, right? I want 45 degrees less than that. That's the angle that has a cosine of negative root 2 over 2. You guys can check your answers after you finish drawing your diagram by putting your calculator in degree mode and typing inverse cosine of negative root 2 over 2, and you should get 135. Same with the previous problem. Remember, you are always welcome to pause, rewind, restart a video if you are struggling. Okay, so tangent -1 of root 3 over 3. So what angle has a tangent that is root 3 over 3? Well, remember, as soon as you see a root 3, your brain should go to a 30, 60, 90 triangle. Okay? Because across from the 60 is root 3. What angle, 30 or 60, would give me a tangent of root 3 over 3? Well, let's try 60. Tangent is opposite over adjacent, right? If I use the 60 as my reference angle, opposite over adjacent would give me root 3 over 1. That's not what I want. So then we know that it can't be 60. So then I'm going to look at the 30. Opposite over adjacent. That would be 1 over root 3. And if I rationalize, I get what I want. Root 3 over root 9, which is root 3 over 3. So that means we want to use a reference angle of 30 degrees. Okay? Now, inverse tangent is restricted to quadrants 1 and 4. So we're either going to want the triangle in quadrant 1 or the triangle in quadrant 2. Okay? Both of them, however, have a reference angle of 30 degrees. So across from 30 is a length of 1. So in the first quadrant, it's a length of +1. In quadrant 4, it's a length of -1 because you went down 1. Hypotenuse is always positive. And in this case, across from the 60 would be the root 3. Now remember, your angle has to be between -90 and +90. So if I use +30 and I do opposite over adjacent, that's going to give me positive root 3 over 3, right? We just proved it over here. If we use 30 degrees, positive 30, I'd get 1 over root 3, which is, after rationalization, root 3 over 3. I don't want to use -30, so look at the right. If I would have used -30, then I would have gotten negative root 3 over 3. And that's not what the question was asking. Okay? All right, so what angle has a tangent that is positive root 3 over 3? That is 30 degrees. Okay, how are you guys doing? All right, let's try the next one. Cosine inverse of -1. Okay, so 1 is in both triangles, right, as a side length. So think back to your two triangles. A 1 appears on both triangles, but the only triangle that has two ones where it could give me, right, where you could reduce down to 1, so cosine, remember, is adjacent over hypotenuse. So the only triangle that has the possibility of giving me a reduced ratio of 1 would be the 45, 45, 90. But think about it. If I take the cosine of 45, that's adjacent over hypotenuse. Adjacent over hypotenuse. And that ends up being root 2 over 2. That's not what I want. So no matter which 45 you use, if you try to find the cosine of 45, you're going to get root 2 over 2. So again, the 30, 60, 90 was not a possibility because no matter whether you look at the 30 or the 60, adjacent over hypotenuse would never give you -1 or 1. This means that none of these triangles could possibly give me what I need. So there is no triangle. There is no adjacent over hypotenuse. There's no possible right triangle, special right triangle that would work. So then that should give you a heads up that this is a quadrantal angle. Quadrantal angle. Okay, so if it's a quadrantal angle, let's focus on our restrictions. We are restricted between quadrants 1 and 2, between 0 and 180, right? So we know it's a quadrantal angle, so it's got to be one of these ordered pairs. Remember that x is your cosine and y is the sine. They're asking me for the cosine inverse of -1. So essentially, we're asking what angle has a cosine, aka x value, of -1. That's this guy right here. Now remember, you've got to give an angle, you have to give your answer is an angle between 0 and 180. So if this is the initial side, the angle that lands here as a terminal side is 180 degrees. So the correct answer here would be 180 degrees. Don't mind me while I take half an hour to erase all that. My computer's a little delayed. So cosine inverse of -1 equals 180 degrees. So we tried to figure out if adjacent over hypotenuse worked with our 30, 60, 90 or 45, 45, 90, but no matter what angle I used, 30, 60 or 45, it just wasn't working. So that means it has to be a quadrantal angle. All right, tangent inverse of -1. So I'm going to try to see, right, if a 30, 60, 90 triangle could work to help me get my ratio of 1/1, essentially, right? Tangent is opposite over adjacent, so that would, right, be -1/1. Okay, so 30 opposite over adjacent, that's not going to reduce to -1 or 1. So it can't be 30. What about 60? Opposite over adjacent. Nope. 45. Opposite over adjacent. Yep. So then you know it's going to be a reference angle of 45 degrees. Okay, so tangent, you're allowed to give an angle between -90 and 90. We know that the reference angle is 45 degrees, so we just got to decide, do we want the angle that goes in quadrant 1 or quadrant 4? Okay, so across from 45 is a 1. Across from the other 45 is also a 1. So you fill in the rest of your side lengths, except this one is going to be -1 because you went down. Okay, so which angle do we want? Which triangle do we want, red or blue? Well, let's try it. If I use the red one, opposite over adjacent would give me +1, and that's not what I want. If I use the blue one, then I would get opposite over adjacent with the -1 included. So then that's going to be the one I want. What angle is 45 degrees below the x-axis within those quadrants? So that angle is -45. The tangent inverse. So what angle has a tangent of -1? -45 degrees. Right? I'd have to go, it's this guy. I'd have to go down 1 to get that negative. Okay, next one, sine inverse of 1. So what angle has opposite over hypotenuse that reduces to 1? Could it possibly be 30, 60, 90? Right? Could it possibly be this one? Well, let's try 30. Opposite over hypotenuse? Nope. That'd give me a half. 60 degrees, opposite over hypotenuse? Nope. That would give me √3/2. What about 45, 45, 90? Opposite over hypotenuse? Nope. Look at the other 45, same thing, opposite over hypotenuse? Nope. So that means that it is a quadrantal angle, meaning it lands exactly on the x or the y-axis. So for sine, you're restricted to quadrants 1 and 4. So you're going to look at the quadrantal angles that land in that area. Remember that sine, since we couldn't use opposite over hypotenuse because there was no triangle, you need to know that the ordered pairs for quadrantal angles, x is the cosine and y is the sine. So what angle has a positive y value of 1? That's this guy, right? So what angle has a y value of positive 1? And that's your answer. What angle has a sine of 1 or y value of 1? We knew it was quadrantal because neither 30, 60, or 45 worked as reference angles to give me opposite over hypotenuse that reduced to 1. So that angle, right? So think from the x-axis, that angle is 90 degrees. Okay, as always, guys, if you need any extra help with anything, please feel free to reach out and ask us for help. Okay, we're here to help. All right, have a good day, guys. Thank you.